Thank you for clicking on this video. Now we are ready to solve our first physics problem. One-dimensional motion, problem number 1. I took this problem from the book of William Basicus, Don't Panic. I modified it, and this is our first problem. A rocket-propelled car, initially at rest, has its engine fired at time moment 0. The car accelerates along x with projection of acceleration equal to alpha, where alpha is constant, times t, where t is time. And alpha is given. It is 3 meters per second cubed. Find the position of the car after 2 seconds. Okay? So here's the car, sort of. What do we know? We know that at time moment 0, velocity of the car v naught x, initial velocity, was 0. And then the car accelerates, and acceleration is function of time. We need to find the position at 2 seconds. What do we do? Well, we wrote our formulas in the previous video, and I do hope that you have these formulas in front of you. So please keep them in front of you because we will be applying them. Do remember that if I know the acceleration of the object as a function of time, I can find its velocity. V sub x as a function of time is equal to integral ax of t dt. It follows from definition, and we did it in the previous video. What I need to do next, I need to plug in here acceleration. You might ask me, why in the world I'm looking for velocity? I was asked to find the position. But can I find the position immediately? No, I cannot do that. I have this acceleration that changes with time. So what I need to do, I need to find velocity first by integrating the acceleration. And only then I will look for position. So this is my indefinite integral. It's not plus. It is equal to, I take this integral. It is alpha t squared over 2. Indefinite integral plus constant, arbitrary constant that we need to find from initial conditions. We are given initial conditions. The car was initially at rest. So Vx at time moment 0, I plug in time moment 0, t0, the first guy is gone, plus constant is still here. And at the same time, I know that v velocity, x projection of velocity at time moment 0 was 0. So constant is 0. We found the velocity of the object at any time moment. Vx as a function of time is just alpha t squared over 2. Next step. Now I know velocity, and I'm ready to find the position. Where do I write? Let me write here. You will probably see it better. What is the position? I know how to do that. I need to take integral of Vx of t dt. We derived these formulas in the previous video. Integral, what is Vx? It is alpha t squared over 2. Alpha is constant, t is a variable. I remember it when I'm taking this integral. What is this integral? It is alpha t 2 plus 1 cubed over 3. I'm sorry, over 3 times 2 over 6. Are you with me? Plus constant. You don't forget about this constant. We need to find the constant. How do I find constant? I use the initial conditions. X at time moment 0. Time moment 0, this guy is 0. Constant. And this constant is different from this. We find it every time from the initial conditions. What was x at time moment 0? At time moment 0, the car started from the origin, so the constant is 0. And now we know x at any time moment. What is x at any time moment? It is alpha t cubed over 6. Alpha t cubed over 6. This is our big step. We found x at any time moment. Now I'm ready to find x at this specific time, 2 seconds. Alpha is 3. Then t is 2. So 2 cubed is 8. 2 cubed is 8. And divided by 6. What do we have? We have 4 meters. We found the position of the object at 4 meters. Big picture. We were giving acceleration as a function of time. We integrated it once to find the velocity. We found the initial condition for the velocity. We found the constant of integration from the initial conditions. We integrated velocity to find the position at any time moment. And then, after we found the position at any time moment, I can plug in 2 seconds, and I know where this rocket-propelled car was at 2 seconds. It was at 4 meters.